Okay then guys, a little intro for the trapezium rule. Here's the formula here. It's best explained by examples, and there's 20 questions in this section for you to have a look at. Here's the formula. These are the y-ordinates. You basically have a curve and you want to approximate the area under the curve, and the trapezium rule basically draws a series of rectangles and makes trapeziums out of them. And it uses the formula here. Area of a trapezium is half of the sum of the sides times the distance between them. So the distance between them, each of these sides that you draw underneath the curve, is called the interval distance. And then you'll have your x-ordinates along these interval points from x0 up to xn. Corresponding to that, you'll have y0 to yn, these y-ordinates here. And this is what you evaluate in the formula. H, as we said, was the distance between the intervals. So here's the formula here for the trapezium rule. So it's fairly straightforward to use in practice, and it comes from this bit of bookwork here, which I'll just briefly take you through. It says an area of a trapezium, the general formula, is half the sum of the sides. So you take the first one, be half of the sum of the sides multiplied by the distance between them. So this is the arrangement we've got that we construct according to this template for the trapezium rule. And then we work out the sum of all these trapeziums to approximate the area under a curve between a start point and an end point. The start point is A, the end point is B. The distance between them, h, is b minus a over n, and n is the number of intervals. And there's of course n plus 1 number of ordinates. So, the sum of the trapezium then, well, a half of the sum of the sides, so that's y0 is the length here and y1 is the length there, times the distance between them is h. Then moving on to the second rectangle, again it's a half of y1 plus y2 times the distance between them h, and then it's a half y2 plus y3 multiplied by h, and you carry on like so in the same manner until you get the second from last one, which is a half of yn minus 2 plus yn minus 1 times h, and then the very last trapezium is this one here. It's a half of this and this added together multiplied by the distance between them, and then it's just a matter of adding them all up. So there's a h over 2 common in all these terms, isn't there? So we can take that outside a bracket here, and then you've got the y0, then you've got two y1s inside the bracket, you can combine them, and then you'll have two y2s, combine them, and then there'll be two y3s, of course, all the way down. And I put dot dot dot, and let's just look from the other end now. We'll have a yn, and then if you look at the yn minus 1, you'll get two of those. And so you'll see that all the middle terms are multiplied by 2, and then you get the first and the last. So slightly rearranging that, in the formula you get the first and the last added together, here and here, plus two lots of everything in between, all the y-ordinates in between. And that's it. That's trapezium rule then, and as I say, it's best explained by examples. There's 20 questions in this section, so all the best guys, and I'll catch you in the next section. Cheers!